Greetings and welcome into my channel. Happy Tuesday evening. I hope everyone's doing well. I am Professor L, and I am going to be hosting this live stream for math help. So, maybe you could, if you need help with your math, maybe you could post a problem in the chat and let me see if I can try and work it for you. In the meantime, I'm going to be working on my board, and I'm still going to be talking about force vectors. After I left the stream yesterday, I realized that I didn't calculate the angle the resultant vector makes. And so I decided to go ahead and try and finish this problem and calculate that angle. And what you do is you use tangent of theta. So since I already have these values and the resultant, let me see if I can just find it real quick. Where was I? Okay, the magnitude of the resultant. So we have vector, so we got 149 and 138. I just need to find out which one's the sine and which one's the cosine because it's important. Tangent is opposite over adjacent. And then also in an earlier video, I showed that tangent was sine over the cosine. And so we want to make sure you have the sine over the cosine to calculate that angle correctly when you enter it into your device. So it looks like I have here the x is 149 and the y is 138. So real quick, I'll just put it here in the corner and try and get out of the way. It's kind of cramped. So you have tangent of theta. Let's see. So you have tan theta equal sine over cosine. So you have y over x. So it's going to be 138.2 divided by 149.3. And then to solve this is a very general, it's actually a trigonometric equation. And what you're asking, what it's asking you is to solve for theta. So you're looking for an angle whose tangent is equal to this ratio, 132 or 138.2 divided by 149.3. So to solve any equation in the world, what you're doing in essence is you're performing inverse operations, and so that's essentially what's going on. So the inverse of tangent is going to be the inverse tangent function. So you got tangent inverse, and what tangent inverse is expecting into its parentheses here is an actual ratio. So you'll say 138.2 divided by 149.3. And then I will just plug this in the calculator and get an approximation. And so I have inverse tangent 138.2 divided by 149.3. And it's giving me a decimal. Let me see if I can get in here. But we're going to go ahead and convert this to degree measure. It's giving me 42.78898. But if you do have a graphing calculator, it will have an angle button on it, and it will, it's usually in the second menu. Mine is it's the 1, 2, 3. So it's the third row, second column button. But it'll have that angle. So you'll have degree measure to from degrees back and forth to angle measure. So it's degrees, minutes, seconds is what it stands for, DMS. So you've got 42 degrees, 47 minutes, and 20.338 seconds. And that is what it is if you wanted to draw that resultant, you could draw the resultant. And what it's saying is that is the degree measure of that resultant vector. So that is going to be from true north because it's a bearing. And so what you would do is you would just draw your, it's about 45, a little bit less. And so then if it was a rough sketch, you draw your little vector, resultant vector in there. And yeah, so it's wild that it ended up back over here rather than in between them. It should be in between those two. So we've got 21.6 and 49.28. So anyway, all right. So that is the end of that problem. And there's something wrong in that, the last part of it. I'm unsettled about where that vector ended up. So it has been a while for me, and that's the reason why I decided to go ahead and pull this subject. And yeah, so Tuesday feels like a Wednesday, and it's a weird phenomenon. But let me go ahead and get my eraser out. We'll just scrap this whole thing. We can keep the title. I picked out another problem. So went back and forth. There are a lot of applications about using vectors and splitting up your vector into its x and y components. And so I think I'll just go ahead and work one more of these, and then we might get into some of those incline diagrams. I was looking at those yesterday. I was just enjoying doing them. So the weight problems, and it's introductions. It's something that you would cover either in a math class or like early physics. So that first lab physics that you have to take, I guess it's kind of an intro level physics, but I had it and it was a lot of fun. And this is where we spent the most time working on these force diagrams. But we did cover as an application extensively in trigonometry class as well. So it's where you would probably see one of these problems pop up. This one is asking to find the magnitude and direction of the resultant. Okay. So we'll say find okay, so find the magnitude and direction of the resultant force, and recall what a force represents. And a force, okay, force vectors. Okay, so F, okay, equals the magnitude. So I'll just say V, the magnitude of V times an angle theta. So if you have, let's see, that is a formula I completely made up, because I'm sure that it's stated somewhere else. So I want to go ahead and put it here. So you have your force. So what you have is your forces. So you have an F sub x equals, so it's going to be theta, wait, it's the magnitude times cosine theta, and your F sub y is going to be your magnitude times the sine of theta, and then your angle theta is going to be found, this is the resultant theta, will be found by sine theta. Here, I'm going to scratch that. I'm going to say that. I'm going to say that's the force, the resultant force. The resultant angle. Use tangent theta equal the resultant force of y over resultant force sub x. All right, that's probably the best way that I can go ahead and put that in there. I'm trying to be practical, and I have never necessarily taught any kind of physics course or anything like that. So I'm just trying to gain a skill here and try to get some practice and have some fun. All right. So if you have an angle, so you have a vector is measured from the horizontal. So if you have a horizontal line, the angle is always measured from that horizontal unless you're dealing with bearing. So if it's a reference angle, in these problems that I've picked out in this old trig book, that's bearing. So you have north, south, east, west. And that's kind of where the confusion comes in to play, is because is how theta is given to you. If it's a bearing, it's got to be measured from north. And I believe the way that it works, yeah, I have to see, I'm remembering what I need to go and ask. So in presenting this is very valuable for me. But I need to go and remember if it's northwest, you go that way. And if it's northeast, you go this way. And then if it's out of the south, I think it's direct out of the south up this way. I'm going to read it. I'm going to have to remember. It's kind of complicated, but in this problem, that's what it's asking us to do. And so we'll go ahead and let me write it out here. It says, and I'm going to try this one. It says 47 pounds acting north 23 degrees 10 west. You know what I could do real quick, since I have the computer. I'll go ahead and just ask where this angle is lying. That way I don't know. It's not like a, okay. North. And then I'll know automatically. It's in the northwest quadrant. Okay, good. So you're going to show me a picture. All right, so that's exactly what I thought. Okay, so 25 degrees east. All right, so this is the problem, and yeah, I just pulled this from somebody, but it's okay, it's just a picture. So it has all these listed. 25 degrees east north. and it's putting it there. And then it has one 45 degrees west of north. Okay, so I'm glad that I remembered that correctly. And then 30 degrees east of south would be pulled up from the south. And then, yeah, so it's just that I don't, I remember, I just don't have a lot of confidence in what I remember because it's been a long time. So, all right, that helps me to go ahead and confidently just sketch these two. So the problem, let's go ahead and write it out. And so we all have it, and it says 47 pounds acting. So we've got vector, we'll just label it vector 1, and this is the notation for vector. And this one is at 40, not 40, it's 47 pounds. So you've got to have a force, so magnitude of 47 pounds, and north 23 degrees, north 23 degrees and 10 minutes west. And then vector 2 is 163 pounds. And it's acting south 84 degrees. And 30 minutes west. So I am going to do my very best to kind of just estimate where these would be. So north, so if it's out of the north, then it's going to be this direction and only 23 degrees. So this first vector is going to be like right in here somewhere. And we'll just say theta of first vector. See, this is the reason why I'm working this problem again, is I kind of want to just see if I can do a little bit better job. So this first theta that you're dealing with here, theta sub 1, is going to be 23. Let's go ahead and just get the decimal for it. So if I have this thing, okay, let's put it in there. 23 raised to it's saying it's 23.166 repeating. So 23 degrees, 10 minutes is roughly 23 point, I'll make sure 16. And the second theta, let's go ahead and write that one in there. Let's draw the vector in. Okay, south 84 degrees, 30 minutes west. So you're at now out of southwest here. So we're going to say out of the south 84 degrees. So there's 90 in here. So it looks like it's going to be real close here, maybe right in there. So there's 90 degrees in a right angle, and then your theta is going to be here. Theta sub 2. So let's see, that's going to be, let's go ahead and put this one here. 84 degrees, 30 minutes is approximately 84.5. So we'll say 84 degrees and 30 minutes west. Oops, we don't need the bearing now. We're just going to deal with theta. So that is going to be 84.5. I should have realized that because that's 30 minutes and it's half of 60. So, all right. So we have, there should be a resultant in here somewhere. So I'm estimating that it's going to be in here somewhere. But what we're going to do is we're going to split both of these vectors into vertical and horizontal components and see if we can't find their the vector. And I think we have to keep track of sign change. And that might have been the reason why I didn't find that other one. All right, just a thought. All right, so let's see what I got to do next. I'm going to use these formulas and I'm going to take both of these vectors and I'm going to split them up into horizontal components. So if I just want to deal with that first vector, so vector 1. Okay. So we have the magnitude is 47 and the theta is 23.16. And vector 2, so we'll go ahead and deal with that one first. So we have the force of sub x is going to be 47 cosine. Let's see, I need to draw this. This vector out here. So we're splitting that into horizontal and vertical components. So the x and the y of this angle. So we've got 23.16 and f sub y is so we'll say 1 and 1. 47 sine of 23.16 and we've got b sub 2 here. The magnitude is 163 and the theta is going to be the south here. So f sub x sub 1 is 163 cosine of we'll just try and see how it works out. I could be working this wrong. 163, I don't think I am, but I could be because this is uncharted territory for me. 163 cosine of this other angle, 84. Oh, I have it right here. Let's see. 84.5. So this would be 163 cosine of 84.5, and then F sub Y sub 2 is 163 times the sine of 84.5 X and Y. And let's just see what happens. All right, so let's find these values. The first one, 47 cosine 23.16. We'll keep it decimal for now. 43 point, I will say 212.27.651 and circle it. And then do the Y component. And I'm saying 18.45. So 18.4851064, and that's it. And then go down to the next one, and we'll type that one in. The next one, 163 times the cosine of 84.5. And I'm getting 15.62. Okay, 15.62285766. Box it. And then 163 sine. Oops. Sine. Oh, 84.5 now. 162.2495803. Okay. All right, so now the resultant should be just adding the components together. So your resultant angle and resultant force, we'll put that here. So R sub X equals F sub X sub 1 plus F sub X sub 2, and R sub Y is going to equal F sub Y sub 1 plus F sub Y sub 2. Again, we're doing this algebraically. There are some geometrical methods that I really want to practice before I present up here. So maybe coming next, we'll see. But for now, we'll just deal with this. And so we're just going to take this 43.2 and add it to 15. So 43. This one plus this one, 15.6228. 766. So I'm getting for this one, I'm getting 58 .83513417. And if I butcher this problem, I'll go back and study it. It'll give me something to do. Again, everybody's got to start somewhere. I feel like that's part of the reason why people don't like math, but I mean, it's an adventure. It's exciting, you know. It's probably the reason why I like it is it's just a challenge for me. Challenge my mind, my brain. All right, so y. Now we've got 18 and 162. So 18.4851064 plus 162.2495803. I'm getting 180.7. So the components, so the x and y components of these fourth vectors okay, I don't know what to do. I was like, wait a second. I have drawn a blank. Okay, how to calculate the magnitude. How to calculate the magnitude. Let me get in this real quick. Click that out. Oh, those dialog boxes that pop up. You can't get rid of them sometimes. Why always in the middle of the live stream when that happens? All right. So since we have these values, we are now going to plug into, because we have an x component and a y component. And so this is the y and this is the x. So now we have to use the Pythagorean theorem to find these values. Okay. So what we're going to do is the Pythagorean theorem is to find the magnitude of the resultant. So let's put that in here. All right, magnitude of the resultant vector v is going to be the square root of the x squared plus y squared. So we've got the 58.8 squared plus 180.7 squared. We'll plug that into the calculator. And if I'll do it real quick and see 58.8 squared. One more parentheses in there. 8.8 squared plus 8.7 squared is again 190. And does it make sense? The magnitude of the resultant 190. 0.0261298 and using approximation there. We'll box that one. So apparently that's the magnitude. There's the sine of the cosine, so we'll put the tangent in here. So we've got this tangent here. Right there. So we've got tangent theta with the parentheses, and you're going to put your y over x. So it's going to be 180 0.8 divided by 58.8. So there's an equal sign in there. I'm not going to fix it. Tan theta. So to solve this, you're just going to use the inverse of tangent. So you'll say tangent inverse of theta. And you put 180.8 divided by 58.8. And then just put that in the calculator. Inverse tangent 180.8 divided by 58.8. All right, saying 71.98. However, we would be over here in either the second or third quadrant. Second, so we've got to either be, I'm suspecting that it's a negative angle from the north. So 71.98. So it's like right here somewhere. Theta of the resultant. That. Okay. Let's see here. Looking at it. I am gonna have to plug this in after I finish and make sure that I did this correctly, check my numbers. Just probably use Google for it and make sure, because it's a problem that's an even number in a really, really old textbook. So what I will do is 40 minutes in, and I will go ahead and stop there. That's plenty of time for me for the day. And we'll just pick it up again tomorrow. So again, if you are watching my videos and finding some sort of edification out of that, I really do appreciate it. It does help me when I look and I see at least I have a couple people watching it. It's not so daunting, but I'll just take what I can. I haven't really been advertising this too much, so I just feel like I want to get really good at it before I go and start saying, "Hey, I'm out here on YouTube somewhere." But it's not the point to be perfect. Okay, so the point is just to keep showing up and doing the very best that you can and giving 100%. So those types of things are more important than being perfect. So again, if you watched my video and you enjoyed it, I really do appreciate that. Thank you so much. And again, have a wonderful rest of your evening. And I will hope to see you back again tomorrow, same time, same place. Okay, bye for now.